Thank you, Todd, for the introduction. So yeah, so I think it will be a little bit of a break from focusing mainly on Polarion, because I'm going to talk about how to integrate your, the whole engineering environment, which is a set of tools. And I'm going to focus a lot about how you build your application interfaces, so we have a better integration between these tools. I mean, if you're developing any modern sort of relatively complex product, you're going to be using a lot of engineering tools to build your application. This is just a small sample of applications that I hope you're familiar with. Just a small. I assume you probably have tens or even hundreds of such applications in your organization. But you're working on a common product or a set of products, right? So the information being authored by these applications are really interdependent and interconnected. If I'm to give just a simple example, you might be using Polarion for your requirements, but you're still using Jira to do the planning. So your tasks in Jira. So you might have some questions. Okay, which tasks are being implemented by implementing this particular requirement? You might have direct connections, so you can actually answer that question if you have such an integration, or it could be sort of implicit, but you need to work it out. But anyway, there are dependencies between Polarion and Jira, whether you have it digital or not. And of course, this is just a simple example. You have a lot of such integrations between the actual data. So we talk about tool integration, but if you think about it, it's really about the data that you have in these tools. How do you integrate this data? Yeah. And this is sort of the problem I'm going to discuss a little bit today. So how do you go about solving this? Typically, and a very effective way of doing that, and that's what you will see actually in Polarion, is to do what we call this sort of point-to-point integration or a synchronization. If you want to answer that question I just gave, which tasks are implementing this requirement, you will import the information from Jira. You might have a job that regularly synchronizes the data from the relevant data from Jira into Polarion. You will need to do some sort of transformation because Polarion doesn't know like exactly the Jira structure you're getting from this API. So you will manipulate it, you do transformations of it. Some custom fields from Jira might be interpreted or sort of changed, and then you put it in Polarion, and then you do your integral. Then you can answer that question because you have the information there. And this works very fine. What happens then is other applications also need this information from Jira. So you will be doing the same job in other places. This is typically what you do. And there are other ways of doing it, but this is sort of the short-term, very effective way of doing it. The problem with this, I hope, what I'm trying to highlight is you will end up with sort of a scalability cost because you have to duplicate this sort of mechanism of importing data, synchronizing it, making sense of it in multiple applications. Every consumer needs to do the same kind of activity. And this is why people, when we talk about point-to-point integrations, that's like sort of a derogatory term in terms of integration because it's not really the right way to do it kind of way. But it's pretty effective. Other problems is, you will end up with inconsistencies because you do need to interpret the information from Jira. If I say tasks, that's a standard term in Jira, so everyone understands it. Maybe that's simple. But you might have some custom fields in Jira that you've added. What do they mean? Then you might need to guess. You might need to talk to the people managing Jira to understand what that means. And you might make different decisions in these transformations. So the data will sort of converge from these different transformations that you've made from the same source of information. You're sort of making a tight coupling, so that's what you need. If things change in Jira, you might need to update your transformations. So that's architecturally, it's not a good thing to do this sort of kind of transformations. You're making a lot of dependencies between the tools. And then just another example, this master data. What happens when some other tool imports that data you got from Jira, from Polarion, from MATLAB? You don't really know whether it's coming from Jira or MATLAB. So you lose control over that information that's sort of being transformed, interpreted, misinterpreted, ends up somewhere else. And if we talk about this thing with digital thread, you've heard the term, that's really what it's about. How do I track information in my whole environment? But I want to make sure I get the right information. So we can't afford this problem with inconsistencies between the data. There are other ways of doing it, but there is something attractive about doing this with point-to-point because it's pretty fast and effective. You have a particular need, you import the data to answer that particular question. I won't have time to talk about the other approaches, but I'm happy to discuss them also. So we like this way of working. How do I do this point-to-point integration? But how can we do it in such a way so that we don't end up with these sort of problems I've highlighted with inconsistencies, etc. And the idea we have is what we're calling sort of producer-based point integration. What we think you should do instead is instead of doing this transformation on the consumer side and try to guess, let the owner of the information that knows what this means do that transformation instead. So of course, if it's Jira information, it should be done on the Jira source. And then you make this information available in real time for all other applications to consume. So we put what I have here is this web service. It's, put them on the web, make this information available 24/7, which means all consumers of this information don't need to copy it anymore. If you trust that this information is available 24/7, you can just grab it at any time, and you don't have to interpret it because it's already well defined according to the way Jira thinks it should be done. So this is sort of what we call a producer-based point-to-point integration. The main difference between this and the consumer-based point-to-point integration is that it sort of scales. You still have as many connections in both cases. If you want information from a source, you should go to the source and grab it. But the cost of doing that is pretty small because you're doing the integration once, the transformation once, and it's correct. So we're gaining the benefit of using point-to-point integration, but without the problems with consistencies and scalabilities. And that's the kind of integrations we're sort of driving through to do it that way. And this is not really, so of course, every such system will provide such an interface, a web interface, where you do the transformation, and then all other systems can just connect and do it. The challenge with doing this, though, just to be fair, is if you're doing that transformation, you need to understand who's your consumer. So you need to provide the information of relevance to all your consumers so that you don't get away from that. But instead of letting the consumer do that kind of logic and interpretation, do it centrally where it's owned, and then allow people to connect to that. So instead of copying and synchronizing and ending up with consistencies, keep it at the source and make it available in real time. So people can just grab it when they need it. This is not really what we're promoting. It's not our own invention. I'm not sure if you've heard of this Oasis OSCC integration standard. I normally talk a lot about that, but that's the sort of most relevant standard for integration if you want to do this sort of digital thread needs. And the idea with this Oasis standard, and it is a standard about integrating engineering applications, or lifecycle applications we call them, is actually that. Let's be inspired by the architecture of the internet. Let's put web services on every node we have, on every application we have, to make available information to all the consumers. A very good example of this is MATLAB Simulink. You have a lot of files in MATLAB Simulink. That means every application that needs information from Simulink models will need to import the information and do it. And you need to copy it and keep it there because it's just files. If we put a web server in front of MATLAB Simulink, you can always ask this information at any particular, at any point in time, you can ask for this information. And that reduces the need to actually do the copying because you trust it's there anytime you need it. So we follow the architecture of the web. You standardize the interfaces. What we've done in the OSCC standard, if you have a requirements tool, you know that you can grab requirements from it. So it doesn't matter if it's Polarion or if you have something from another vendor. Any consumer of requirements can know that, okay, I'm grabbing requirements. It's already defined as a requirement object, so I don't need to do any transformations. And that's the idea I've said of putting, sort of doing the transformation of the source. That's one way of interpreting the standard. And then you also try to minimize this. So if you try to understand what your consumer needs and just give enough information out to satisfy those particular needs, and you do it incrementally. So if there's more integration needs, you increase your sort of what information you're providing out. Polarion has a lot of work item types, lots of custom fields and stuff. A standard Polarion API can give you a lot of information, but maybe you should minimize that to the minimum possible for the consumer so that they can manage it. So we're following this approach of the OSCC standard. We're just trying to simplify it. But when I normally talk about standards, people, it gives the impression that you need to apply it on all sort of your whole tool chain, and it becomes a bigger decision. And my experience is that we struggle to make that work because the focus is so much on the whole architecture or everything. But I try to reduce this. If you don't like reading standards, I try to reduce it to how can I improve my one point-to-point integration for a particular application. So with these ideas I've had in mind now, I've told you about, how can I do a single integration between, again, Jira and Polarion? How do I define my API for my particular application? And I can reduce it down to these 5 basic principles, just to make it simple. As I go through this very quickly, the payoff is you don't have to think of optimizing the whole tool chain. This should be enough. to do a better integration between two tools. Of course, the more tools you have, you will pay off more, but it shouldn't be a big investment to make a gain out of this kind of integration. I'll go quickly through this, but the most basic idea is, make your information available 24/7. Put a web service in front of your applications. It sounds very trivial, but if I take the example of MATLAB Simulink, where is your data? It's in files. Okay, so every consumer of this information needs to grab it somehow. Is it on a file system? Is it on a Git? Where do I do it? Put an interface in front of it, make it available as a web service, then anyone can grab it in a pretty standard way. Provide the data according to a domain model. I can actually stick to explain this one, to MATLAB Simulink. If you grab data from MATLAB, I'm thinking mainly of Simulink models, right? Everything is a system or a subsystem or a block or a connector. This is quite generic. What you want out of your API is the domain of your own organization. Maybe it's a component or a feature or a function, depending on how you're using Simulink. So make this API available in the language of your organization, in your domain. Once you share the information, give a global ID. So you can always go back. I can talk years about this one, but just to stick to it for now. Every object in your whole organization should have a unique ID, so you know exactly where it comes from. So Simulink objects should have one type of ID, and if it's from Polarion, it should have another type. But you should know where it comes from. You should understand that this is a Simulink object, this is a Polarion object. I can talk a lot about that one, but I won't. And when you think of integrations, there are two types of needs. One is for consumers, as I said, like you want to do analysis kind of thing, so that's integration for the machines. But think of us, the humans. So if I want to create a traceability between my requirements in Polarion and my task in Jira, maybe you should make it easier for the human also. This API should give an interface for the humans to create this traceability link, because not everything is ChatGPT and API yet. We humans need to be involved in making that connection. And I can talk more about that in a second. And these domain models I talked about, we always, I've been part of research projects where we can spend many hours trying to define this global organization level information model. This doesn't hold, it doesn't scale. So you should really work on this locally, maybe per application, but you should also coordinate that. So it sort of fits together, of course. Okay, so this is sort of the approach we're taking in our solution. We're promoting this way of thinking, which is a sort of a federated engineering environment. We're leaving the data at the source, but you're trying to connect it. When we promote this idea of federation, there's always a sense of, there's a real risk, not just a sense of loss of control. Sorry, I lost track. Is there a question? Because it's you're too close, so I'm a bit distracted, sorry. Yeah. Okay, so if you think of this federated way of thinking, there's a risk that you lose control over your application. And actually, that's not really to do with our way of thinking. If you think about it, how many organizations know what applications they have? I mean, of course, you know the cost of applications or the licenses, but how many have a full control over what integrations you have and what's happening between the information flow between them? So we've developed this application called LynxDesigner that tries to give you control over your applications. You model and design your architecture of your environment, and then you want to do that over time because your application and the information flow changes over time. So you want to have some sort of life cycle management of your whole tool chain. I mean, the same way when you're developing a product, you have, let's say, Polarion to do your requirements. We need a sort of application to manage the actual tool chain, because I think this is becoming a valuable asset for an organization. The information, the product data behind it is a valuable asset. How do you manage that? Which applications own which data? Maybe you need some sort of support, tool support, to manage your actual tool chain. And that's what we're providing with LynxDesigner. So it's a platform for the management of your whole environment. Which applications you have, what integrations you're doing, what kind of data is flowing between the different applications. And there's basically three aspects of that. What is your overall architecture? Maybe you need to define that. What applications do I have? What connections is there between them? The information flow between these applications in the whole tool chain, and then down to an application. What services is available from every application? I will go through a little bit very quickly through each of these. But to keep in mind also that it's not just a thing you do once. It's actually, it never ends. You need sort of life cycle management on when you're doing this kind of Same as when you're developing a product, you have Polarion and you always use it for your requirements. This is a thing you use throughout the whole organization over time, because that thing changes all the time. It's alive. It's not a one-off documentation. Okay, so that went too quickly. But you know, you want to be able, what we're providing with LynxDesigner is an ability to actually model your whole architecture. So instead of having that PowerPoint that you just saw before, maybe you need a digital model of your environment. Which applications you have, which data is flowing, you know, Jira, that's providing change request and defect, and then you know that Polarion is providing requirements, and there's some sort of a connection between them. You want to have an overview of that, and that's what we provide. We provide like a modeling tool to actually get an overview of that architecture. And it's consistent with, I will have to talk about these two later, it's a bit hard. There's like 3 perspectives on this. You have your toolchain architecture, and then you have also a model of your information architecture. And that brings me to that, actually. Oops. Okay, information modeling, and that's another aspect that we support with our tool. But just in general, if we talk about information modeling, typically it's divided into these 3 layers. You have your conceptual model. This is sort of the concepts in your organization that sort of formally or informally agreed upon. What is a use case? What is a part? What is a test assignment? You know, that's what you talk about in meetings. And that needs to be set so you don't have confusions when you talk to each other in meetings or otherwise. That's sort of top level stuff. That's sort of in our heads. At the lowest level, you have your data models. That's like every application. What is the schema? Where do you save your files, etc. And this sort of per applications, your data models. And then there's something in between that I think we or I at least call it the information modeling. This is sort of the independent of the tools, an enterprise sort of catch-all concepts that you have. You typically find them in these process models. If you have this BPMN notation for process models, you see the focus is on the different activities, and you might, maybe I should point with the mouse, you might have some artifacts coming out here. That sort of becomes a term. If you use this Astrakhan kind of modeling, you have your activity here, but then you have input, which is artifacts, and output, that's artifacts. And that's really when you do process modeling. This is where you find what's happening, independent of the tools, what data is coming in and out of your process activities. But it doesn't really talk about what's happening digitally between the tools. So it's pretty high level kind of application, modeling of the information. So if you want to do this digital thread, which has to be digital, then things have to be more specific than that. It cannot be just approved requirement. And my experience is that when you work with process modeling, you don't want to be so exact of defining exactly, you know, what properties a requirement should have. Is it a string or is it a date, et cetera, et cetera. But if you want to do a digital integration, you need to go to the level of an exact specification of things, like a schema of things, but not at the tool level. You want to do it still at the sort of high level, tool chain level. So you want to talk about test plan, test case, test script at a high level, and not exactly maybe what a test plan looks like in Polarion. You want to talk about the resources being exchanged between applications and not within every application. So this is the thing we're finding as a gap in the way you think in terms of modeling in an organization that I think we need support for. And then the third aspect we also support is this application interface. If you have your tool chain, and I know that I need to provide change request, defect, and task, what kind of services should I provide? Should a consumer be able to create change requests, or is it only about reading the change request? Do I provide what we call delegated UIs so the user can search and find a change request? What are the different services you have? So we support that kind of design of the application. Yeah, okay. So, and again, all these 3 things I talked about, the architecture of the tool chain should fit with the design, the internal design of the interface. The information model, if you have a service, a service delivering test plans, then the test plan should be according to the information model. It should deliver those attributes that you expected out of the information model. So it becomes a sort of a connection between the information architects defining the different concepts, or not concepts, the entities being exchanged, and then the particular design of an application API. And we want to support both, again, as I said, the humans and the machines. So this is a bit technical maybe, but if you're a machine, then you like this open API description. These are the consumer applications, they can use it. But if you're a human, this is just an example where I have an IBM product in the background, and I want to connect, it happened to be the case, changes in change management in an IBM product, and I want to have a pop-up as a user to actually select an item coming out of Polarion, and then making a traceability link between the IBM and the Polarion information. And this is a service coming out of Polarion. That's actually out-of-the-box kind of services to make connections. And this is sort of services for the humans, not only for the machines. So we're trying to support both. And really the driving force, as I said, is it should be, we're not sharing files, we're sharing fine-grained resources according to the information model. And we're trying to provide web services, so you always do linking instead of copying information. The information's always there, why copy it? You can trust us that it's going to be there even on a Sunday. So you don't have to save any copies of it. Okay, how am I doing on time? Okay, so, and as I said, now I've shared the three aspects, but again, we want to support this over the life cycle of the product. So it's not a one-off activity. It's actually going to take, it's an endless activity to model your tool chain, keep it updated, and change it. So we're thinking, of course, about the life cycle support, like any other application tool you have. And there's two sort of roles here. You have the information architect, and they would have different needs. These are the people, the architects that define what information is being exchanged. Maybe you start with the process modeling, but then you need to go one level down and be more specific about exactly how should each artifact be coming in and out. If it's coming between tools, I need to define how the object should look like. And then if you're a sort of an application owner, application architect, to be compliant with this architecture, what services do I need to provide? And then you need to support that, and that will change over time also. So this is for an information architect. This is a typical model we define. You don't think of the applications. This is just higher level, where you know you're talking about quality management resources or requirements, and you define it at that level. It's very specific. It tells you exactly what kind of attributes every object should have. You have to have that level of exactness if you want to do it digitally. Yeah? But it doesn't, I don't care how it looks like at the application. It's still about how do I exchange data between my applications. And these models, you want to keep control over them. Who has access to them, who can change them, etc. And we support that using just basic Git a repository in our case. And then we have an editor that lets you do it. So you do the modeling graphically, of course, and it's managed under Git for that. But it's not just a beautiful picture. What you get out of it, what you should get out of that, and that's what you get, is the code. So an implementer of the application can get some support, a digital code and digital artifacts that reflect this information. So when you, from your application, return the test plan, you know that it's going to be according to that specification. So it's not only modeling for the sake of modeling and having beautiful pictures, it's actually executable code you get. Documentation, digital representation. If you're an application architect, you might want to work with these pictures, and this is sort of the kind of service modeling. For a test case, I'm going to allow the user to be able, the consumer, to read, update, and delete. Maybe you say, no, they're only allowed to read. So you design your application here according to the overall architecture. You might provide these query capabilities, selection dialogues. This allows you to do the design. And in the same way, this is all access controlled for an architect, so you have full control over, a little bit like Polarion, right? You put everything in the end, it's a version, you have version control, you have access control, etc. And these interface models must be dependent, or they do depend on the domain models. So you have the information architects doing the information modeling, but then when you design a particular application interface, you connect it to that. And that's why you get full, proper consistency between the two. And we have this sort of low-code approach. I mean, there's quite a lot of technologies doing integration. So given this information, you can press a button, and you get almost all the code you need to actually provide the API. Both the web services, but also these delegated UIs that I talked about. These are not, to be clear, not from us. This is actually, with the standard OSSC, for example, Polarion, out of the box, provides you with these standards. So in our case, you don't need to do, in your case, you don't need to do this for Polarion, because Polarion comes with this kind of technology already. But we're trying to support tools that already support this OSSC way of thinking that I talked about. Then you can get the code for free with this approach. Not for free, but cheap. Not for free. Okay. Yeah. And then finally you have your deployment. So also once you have the code, it's almost running, you can deploy it. And then it should fit in this sort of the ongoing other application. You updated Jira, but everything else is running. So we're trying to provide this whole continuous integration overall picture of how you can update one without the other one. And you don't deploy a tool chain, right? You should be able to do a change in one application and everything else should stay running at the same time. And this is sort of standard way of working when you actually think of components in your application in a way. But we never do that when it comes to the tool chain. And that's what we're trying to build here. Maybe an application to manage your tool chain. Same way you manage your product, you manage your toolchain. Okay, I did manage in half an hour almost. My last slide. So this is actually what we have, LynxDesigner. It's a platform. The same way you have platforms to manage your product, develop them, requirements, testing, etc. We're building a product to manage your toolchain that I think every organization needs, because you need to start thinking of your toolchain as an asset that you need to manage. And it's not a one-off thing, it's a whole life cycle thing. So hopefully, once you get it, you want to use it over and over again. We tried to find this, I didn't get into that, but I mean, when we talk about federated, you lose control. So we tried to find this balance between how do we distribute everything, and every application is independent, but you want to control over it. And this tool gives you that, because you have an architecture there, you keep track of it, you know what information is flowing between the applications and their design. And this is sort of our the way we think it should be done. A lot of, for example, when it comes to information modeling, you should leave these domains. You don't need one central big information model. That just never happens. It takes ages. Maybe you can focus on per application to do your domain model, but then you need to centralize how you coordinate these models so there's no contradictions between them. Maybe you need to have a common modeling approach, so not everyone is doing, and in that case you should use LynxDesigner. But maybe it should be one model, otherwise it's going to be hard to interpret the connections between them. Same as when it comes to the application interface. The development should be distributed, but maybe guidelines and standards should be centralized. So find that fine balance between the two aspects of integration. That's it. Wow, I did it on time even. Thank you for listening.